of g of x is equal to negative 2x to the fourth plus 4x cubed minus 5x today. We're going to graph this and we're going to analyze the different pieces to it. Now we're just going to graph very simply using a table of values, typically using integers unless we need to use something more. All right, now before I get started, I'm going to do my preliminary work so I know how to set up my table. So I'm going to look at the degree, and the degree of this polynomial is 4 with a leading coefficient of -2. So that means it's even and the ends are going to end in the same direction. Because my leading coefficient is negative, that means both of my ends are going to end down in the same direction. So when I'm choosing values for my table, I need to start at 0 and I need to continue to the left and to the right until I'm getting very small values. So that's exactly what I'm going to do. I'm going to set up a table of values, but I'm not going to start at a specific number. I'm going to start at 0 each time. And when I do that, I'm looking to get to a number that's really small here and that's really small down here, and I'm going to keep going until I get there. So we plug these values into the function. So 0 and g of x, g of 0 will give me 0. If I plug in -1, g of -1 gives me 0. -2 is going to give me -46. So that's a pretty small number. I'm going to take it one more time just to see how small I can get it. So if I take it to -3, it's going to take me all the way down to -228. I think that's pretty safe to say that it's continuing in the negative direction. Now I'm going to do the same for the positives. So if I plug in 1, I get a -4. If I plug in a 2, I get a -18. And I plug in a 3, I get a -96. So again, these numbers starting to be very small numbers is pretty safe to say that you've got enough of the graph. All right, so now we're going to plot those numbers. So obviously I can't plot -3, -228, but I know that it's going to end up way down here at the bottom of my graph. So the first thing I can graph is -1, 0, 0, 0, 1, -4, and I can see that 2, -18 is going to fall down here. Now here's the problem. These are polynomials, and polynomials aren't going to come up here and flatten off. So that must mean that somewhere in between here, I'm reaching a maximum. So again, we're just sketching these graphs at this point. So what I'm going to do is I'm going to throw in one more point just to kind of estimate. So since these are even at -1 and 0, I'm going to see what -1/2 gives me. So I'm going to plug that in, and when I do, I get a +2. So I'm going to go ahead and plot that too. So like I said, typically I do as many integers as I can, but if I see something different happening where I'd have to graph this and then come over here and it would flatten off, I know there has to be a point in between. All right, so now I'm going to connect my points left to right. So I know I'm going to start really low. I'm going to start coming up, up, up. I'm going to hit that value and start to come back down. So even though this is a 4th degree function, it looks a lot like a parabolic shape, like a quadratic would give us, and that's sometimes the case. We won't always cross the x-axis 4 times. With a 4th degree function, the most we can cross is 4 times. Okay, so now let's analyze what's going on. So it's asking us for turning points. So turning points are where your minimum and maximums are located. So you can see right here, I have a localized area of a maximum. So I have a turning point at approximately -1/2, and that just happens to be the relative maximum. And in this graph, it's actually the highest point, but we're just going to call it relative max for now. All right, real zeros. Now this is pretty easy in this graph because they fall exactly. They're not falling in between. So our real zeros are going to be exactly at -1 and 0. And you can see that we have 2 of those. Okay. where is our function increasing? So our function is increasing as long as I look left or right and it's getting bigger. So it's getting bigger until I reach that maximum point. So it's increasing from negative infinity all the way to negative 1/2. And I just write it as an interval. So it's increasing from left all the way until I get to negative 1/2. When we get to negative 1/2, it reaches its turning point and it's going to start decreasing. So this is increasing and this is decreasing. Okay, so we are going to be decreasing from negative 1/2, I'm going to write it as an interval, all the way to infinity. Notice I'm not putting equals because I don't know if it's exactly negative 1/2. That's the only point I plotted in the middle. And another thing is we can't ever reach infinity, so I'll never put equals on my endpoints. So what is my domain? So left or right, I'm going to have all real numbers for my domain. Now my range, that's a different story. My range is starting at this value 2 and it's continuing negatively from there. So my range are going to be all values of g of x such that g of x is less than or equal to 2, hoping that that 2 is our maximum point. Okay, so you can see how we graph without being given a table. I started, remember, right in the middle at 0, and I moved left until I got where I needed to go, and then I moved right till I got where I needed to go. I plotted those points, and then I found all of the intricate pieces of our polynomial graph.